In this video we will show the setup of a simple model in noise3D. It is the example model from the noise3D manual. We will go through the prerequisites and the 6 steps from a floor plan to the project. Look at the manual, section 2, noise3D example. You will see exactly what we intend to do here. Eventually you will see how a noise map will be created in that example. Now, which are the prerequisites? First of all, you need to be registered and logged in to the application. Also, you need to have SketchUp available. Both SketchUp Pro and Make will work. This is the starting point. It is an empty model in SketchUp. So once you've called SketchUp, you will see the noise3D icons at the top. The first step will be to set up a floor plan. How will this be achieved? You will actually go into the file and then import function of SketchUp, where you can choose a JPEG file which is to be put at the origin point. It's important that it is the origin point where you put the floor plan. Next, we need to be concerned about the calibration of the plan. We will use the camera tool standard view top to look at the floor plan, and then we will look at the tape measure tool, and we will measure a known area of the plan, which is actually this one, which is 30 meters of length. We will input that length into the length field, and SketchUp will ask us whether we want to resize the plan. That's actually what we intend to do. And you will now see how the plan will look like. Not really different, yet it will be calibrated correctly and prepared for setting up a proper 3D project model. Once this has been completed, we will just save the file and give it a meaningful name. Step 2 will be the setup of our model as a project in noise3D. So we will go actually to extensions and the plugin and choose project setup, which gives us a number of data elements to be input: a project name, then a date, and we can provide comments as well at this point. Next will be to define the grid for the calculation engine. In our case, we will say use model bounds, which means that the entire model will be considered for the calculation process. In the next step, we will set up acoustic objects, which are the buildings on the floor plan, and also a noise source and a receiver point. So we are starting with setting up the first building by clicking on the corner points of the buildings, then hit enter, and the building will be set up with the default height of 6 meters. And as we go, we will also change the height of some of the buildings. Okay, now we will set up the noise source. We will do that by looking at the noise source icon. We click on that and also click on the location where the noise source is to be located in the plan. Once this has been done, we want to add the acoustic attributes of the noise source, which is a number and a name, and importantly the octave spectra for the noise source. We can now complete the process with an OK and move to the next acoustic object, which is the receiver. In order to locate the place, where to put the receiver, we use the orbit tool to move the plan around a little bit, then click on the noise3D receiver item and position the icon exactly in the plan where we want to see it. Again, we have acoustic attributes for the receiver. In this case, it is just the name of the receiver, which we put in and complete the process doing the OK button. Step 4 will be to validate the input that we have done. We have a function noise3D, which you can call from the plugin noise3D display infos, which will then provide to you an overview of objects and attributes that have been input. That is the point source. We can see the receiver and also a number of buildings that have been put into the project. So it looks like we're okay with this input, and we can move to the next step, which is the single point calculation. Single point calculation is another function of the plugin. So go to extensions, noise3D, single point, and calculate. And very quickly the results will be shown in a little table. In this case, we've got only one emission point. Double click and you will see the detail behind that summary information. And you can scroll more to the right and you will see more detailed information about the noise levels at that emission point. The final step is actually concerned with the creation of the noise map. Yet another function of the plugin. Go to extensions, noise3D, and noise map calculate. The noise map will be created. You can choose whether you want to look at day or night situation and a high or low resolution of the noise map, and eventually you will see the noise map. At this stage, the noise map still looks a little bit edgy, and that has to do with the grid size we've actually chosen. Interpolation of the noise map is an opportunity to work on that. So it's a function of the plugin where you choose extensions, noise3D, noise map, and then interpolation. Again, you've got the choice of day or night, and you can enter a finer grid size for interpolation. So eventually you will find yourselves with an interpolated noise map, which looks nicer, but still reflects exactly the calculated noise levels across the map. This completes the sample project, and we hope you will be successful moving on and setting up your own project. But be reminded that this example has been set up in our manual, so I mean you're encouraged to also go back, look into the manual, and look at some more details explained over there.